I was waiting for all this talk for him to utter the word PyTorch 2.0. And finally, he said it. Welcome to PyTorch Conference. This is my first one. I'm Peng Wu. I support the PyTorch compiler team. So as a compiler person, PT 2.0, to a large extent, is really a compiler story. And you might wonder, why does it take so long for us to actually fully embrace compiler technology into the core of PyTorch? And the reason is because what makes PyTorch beloved by researchers is flexibility, dynamism, expressiveness is exactly what makes it very hard to compile. So it took us 5 years of developing various solutions, compiler solutions, to get to where we are. And I want to call the inflection point of our journey searching for the right compiler solution TorchDynamo, which is what I'm going to talk about. So it starts with asking this question: what is one thing that we could change first in the compiler stack that will fundamentally change the efficiency of PyTorch? It's not a new compiler optimization. It's not even a new compiler backend. Actually, the key first move lies in the top part of the compiler, which is the graph capture. So we all know that graph mode execution can be a lot more efficient than executing ops one at a time, especially if you are a machine learning accelerator designer or if you are a production engineer. Unfortunately, for eager first machine learning framework like PyTorch, it's actually non-trivial to get graphs reliably. So that's why we care about graph capture, because it's simple. If you don't have reliable graph capture, you don't have a reliable compiler coverage. So let me introduce TorchDynamo, our first out-of-box graph capture. Here's one example of a toy PyTorch program. And here is this one-liner change torch.compile. And in this example, we actually allow you to specify a custom backend. In this particular example, my compiler basically takes the graph that's captured by Dynamo and do something about it, which basically print it out and return a Python callable. So if you execute this program, you'll be surprised to see actually 3 graphs being printed out, because in this example, we actually put a twist of a data-dependent control flow. So this graph break actually is a feature, is a fundamental design feature of TorchDynamo that makes it out-of-box and sound. So let me double-click on what makes TorchDynamo sound and out-of-box. Number one is partial graph capture. So this is our ability to skip anything unwanted and then fall back to eager. And with partial graph capture, we save the programmers to have to shoehorn their models into what the backend compiler want. Instead, we're just simply transiting in and out of between eager and the graph mode. And then there is the guarded graph generation. Basically, we want to make sure whatever we're capturing at capture time is still valid when we're replaying this graph. And finally, if we did find a mismatch on the guard, we have the ability to just in time recapture them. So basically, partial guarded graph capture with just in-time recapturing is what set Dynamo apart from all our previous graph capture technologies. And by the way, there's this thing called AOT autograph that captures the backward part of the graph, and that makes it working for training. So I want to show you some numbers, which Sumit's already highlighted in his keynote, that would back the claims we made so far. You have seen this 7K plus model, so this demonstrates that it indeed works out of box. And right now we have more than 20 experimental backends for inference that's integrated with TorchDynamo, and we have more than one backend that's integrated with TorchDynamo for training. And the number is smaller on training side, not because of Dynamo, but because there are just less number of training backends available. And we're working actively with vendors to migrate into this new stack. And finally, you've seen this 30% number. What does it say? Actually, it's not only talking about the performance, it also demonstrates that partial graph actually works. So by capturing graphs and allowing graph breaks, we not only did not diminish the capability of the backend optimizing compiler, we actually amplify it by bringing more models or more regions of the models into the compiler world. So Dynamo is great, but if you are an experienced PyTorch compiler user, you would ask this question. So which technology do I use? As of today, we actually recommend using TorchDynamo for any scenarios that can be deployed with Eager. So that includes most of the training scenario and some of the inference scenarios. And for all the other scenarios, which we call the export path scenario, our existing solution still works. But in the future, actually not so far future, we actually want to have an organic consolidation of front-end technology around TorchDynamo. It has always been our vision to have a unifying front-end and have a vibrant, thriving back-end ecosystem. And the speed of our consolidation actually depends on two things. Number one, how fast do we deliver the PyTorch 2.0 export story? And number two is how fast the vendors can migrate into this new stack. So we look forward to that new experience of a consolidated front end. Yeah, so that's Dynamo, and I want to bring you back to the question we asked in the beginning of the talk. What is that one thing, right? So as a optimizing compiler person for 2 decades, I never imagined myself talk about a compiler front end. But the front end part of the compiler, graph capture, really matters, because once we're able to bring most of the PyTorch models seamlessly into the graph world, the era of compiler-accelerated PyTorch really arrives. So if you're excited about this vision, there are more nuanced aspects of the compiler story that you are going to hear today and in the following months. And if you're an ML practitioner, I would encourage you to try out PT2 on your workload. And if you're a vendor, I encourage you to talk to us to explore migrating into this new stack. And finally, we have some talk series that would dive deeper into the technology in the PyTorch 2.0 stack. So with that, I'm going to pass the torch to Jason Ansel.